All right, so you may have seen the energy efficiency pyramid, or many different versions of it. But have you seen the ventilation pyramid? Much like the energy efficiency pyramid, it progresses from cheaper, more do-it-yourself friendly approaches with lower cost, but fewer energy savings, fewer health benefits, and increased risk of building durability failure at the bottom of the list. And as you go up the pyramid, you get systems that, while yes, may cost a little more in the upfront, they have more energy, carbon, and cost savings over time, as well as help with better air quality and less risk to building durability. When it comes to LEED residential and green certification in general, they will all require this baseline system of the bottom of the pyramid to be installed correctly, tested, and then points are given in those green systems like LEED and others as you go up. So please join us for this discussion on the basics at the starting all the way up through to demand controlled smart and everything in between. Before we get started, I want to remind you that support for the Green Home Institute comes from Build Equinox. You know, traditional ERVs and HRVs provide basic ventilation, but often lack protection against airborne threats like seasonal flu and wildfire smoke. So introducing the CERV, an advanced indoor air quality management system. That's what we'll be discussing after the formal session is wrapped up here today. And so again, welcome everyone to Evolution of Ventilation from the basics to smart recovery and everything in between. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be not only the moderator, but a co-speaker for our session. Now, this course is approved for multiple continuing education units, including 2 of the 5 pillars of green, health, and energy in our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out the 5-digit Passive House code at the end. As long as you're here for the entire CEU hour, you will receive that in your follow-up email. We are excited to announce we're now offering International Code Council IECC continuing education credits as a courtesy of our partner Energy Smart Institute for our webinars, both live and on demand. This session is approved for 1 CEU hour in the residential category of the IECC, and all IECC will be self-reporting. Check out the EnergySmartInstitute.com for all your energy rating trainer needs. So with that, I am excited to get started today. Again, my name's Brett Little. I'm the education manager here, and I'll have Victor, our co-speaker, introduce himself too briefly.
Yeah, my name is Victor Niño, Director of Business Development at Build Equinox.
All right, thank you, Victor. So I'll jump into it, and then Victor will be back in again in a little bit. So again, a reminder, energy efficiency pyramids, we're going to start at the bottom, work our way up to the top real quickly into the culmination of where we're at and where we need to be. So supply and exhaust only local exhaust strategies is really the baseline foundational part of our pyramid. Now, when it comes to residential green buildings, these steps in the pyramid are going to lay out what is required for ventilation and give a good, better, and best approach. The LEED residential rating system under the environmental quality prerequisite ventilation requires compliance with ASHRAE 62.2 standard, and so do many other building codes and green programs. Currently, LEED version 4 requires ASHRAE 62.2 2016, while V4 only requires 62.20 to 2010, a little bit diminished in its needs. Now, the new version 5 under the commercial rating system was balloted under the year 2022 for 62.2. We'll assume that residential will follow suit when it's balloted under version 5. So LEED and many green programs defer to ASHRAE, which will be the backbone to our initial concepts and foundation of proper ventilation, installation, and performance, but then we need to go beyond that. So in all cases, the first approach on the pyramid is the local ventilation, which is done through exhaust or supply-only ventilation. In most cases, the kitchen project will have an exhaust only through a range hood or vented microwave, and per LEED ASHRAE standards, this system needs to be vented outdoors, not in the attic, and be tested at 100 CFM, which is basically a measurement of the flow of air at a certain rate per minute. tested by a certified energy rater, and systems that are 400 CFM or higher need some kind of automated automatic makeup air system to replace that huge volume of air being moved. But there is another way to do this, and that's what we're going to discuss as we move up that pyramid. Beyond the kitchen, we need to look at the whole home or unit ventilation systems, which takes a little more thought. In the early design stage of your project, this handy chart of the LEED credit library gives you a starting point of project square feet or meters and the number of bedrooms on where you need to be with your CFM rating for ASHRAE 62.2 compliance. Now, this is typically a worst case scenario number. These numbers tend to actually go down and how much ventilation you need once you get more details on your project as far as air tightness targets and those assumptions, which we will discuss how that works here briefly. The simplest way to do exhaust-only ventilation is a bath fan or multiple fans if there are multiple bathrooms. Per LEED residential environmental quality ventilation prerequisite, these systems need to be Energy Star certified with lower SON or sound ratings and be tested at 50 CFM. Again, that's kind of like airflow per minute or higher by an energy rater. They need to be vented outside. If you're not doing LEED, you can do a simple toilet paper test to determine if it's a proper flow. If it holds the toilet paper, it may be okay. For renovations, this approach is going to be the easiest way to do it than the next one that we're going to discuss as far as ventilation goes on the lower level of the pyramid. We typically see this approach for code compliance here in the Midwest where ventilation requires code or where code requires ventilation. Exhaust-only systems unfortunately create a negative pressure on the home, and if the buildings get too tight, I have to ask the question always, where does that air even come from at that point? So in contrast to exhaust only, you may have an HVAC system that dumps fresh air into the house, like on the left here. Sometimes you see that is, of course, uncontrolled and unfiltered. In many cases, the system is designed only to bring in fresh air when the HVAC is calling for heating, cooling, such as the system is running. When complying with LEED environmental quality ventilation prerequisite, it cannot be uncontrolled and must be set to the ASHRAE standards of proper flow. Either continuous or intermittent is fine. This is the case either for supply air or bath fan. They are set up on timers or continuous running systems to keep the ventilation going. But when I hand it over to Victor here in a little bit, you'll see why this is a concern. And while yes, this certainly does meet LEED and Energy Star, it probably is not a good idea. So on the positive side, though, the supply-only approach may help suppress radon, but on the downside may cause humidity issues such as too humid in the summer and too dry in the winter, especially when there are unfiltered systems in place that dump poor outdoor air quality into the units, especially when those units and housing projects are located in EPA non-attainment zones, which must also then be accounted for in special ways for LEED projects. So moving up our pyramid, we get into systems that are balanced, which are better for health, but maybe not much different on cost and energy savings and carbon savings. They tend to cost a little more and be a little less do-it-yourself friendly, as you move up that area. When it comes to LEED, you can achieve some extra points depending on the version for having balanced ventilation, as it points out here. Under version 4.1, you need to be better than the minimum ASHRAE 62 threshold when you test the system. But under version 4, they actually require you to be within a 10% threshold. So you don't get any points if you're overventilating. And so that tends to happen in our large multifamily projects. Okay, so what is balanced ventilation? Here's a diagram of how it works. You have some kind of supply system with the fresh air bringing it in, and then the fresh air is exhausted by the bath fans. At the same flow rates, they have to match each other, so it creates a balanced air without negative or positive pressure. You might have some fan system in the hallway to help move air around as well. Sometimes these systems can include ventilating dehumidifiers as well, which will help remove humidity issues and also bring in fresh air. This can give you an extra LEED environmental quality point under the enhanced ventilation for having humidity control. All right, so moving up the pyramid, we're almost to the top. This is a quick one. It's unlike the energy one, which is much more detailed. We get into the heat or recovery ventilators. That is a balanced system approach, but also maintains the percent of the energy wasted or lost during the air exchange. So that means cost and carbon is retained, lower cost, lower carbon than the previous two approaches, but this will require more cost to the system and more skilled labor for the installation. Typically, LEED projects, especially ones scoring at higher levels of LEED, are now using the energy or heat recovery ventilators, mostly ERVs we see. They are a simple way to ensure balanced ventilation points, meet the ASHRAE whole house ventilation requirements, and also improve your home's energy rating scores. Now, while scoring LEED or green projects do not need these devices, they can score more on the energy and atmosphere annual energy performance using their energy rating index, also sometimes known as the HERS rating, or the ASHRAE 90.1 modeling by having a recovery system in place. When the energy model or energy models system, the ERV into the whole details of the project, everything goes into the energy model. It will ultimately give you an improved score if you're comparing it to a supply or exhaust only or balanced system only. You'll always get a better, lower energy rating on the chart. Certainly, your score would be even better if you did no ventilation in your project, right? Because ventilation is always going to drag your energy ratings down. But that is not allowed in LEED. It's not allowed in most of the other green programs. And in many cases, a growing number of jurisdictions around the country are not going to allow you to not ventilate. So, how does it work? It's no different than our balance diagram. The only difference is the main device is the ERV or HRV, and it works the same way. It's bringing in the fresh air, exhausting the stale air, bringing in the fresh air. In new constructions, these systems should not be tied to the existing ductwork and should be standalone when using the ducted HVAC system. But in renovations, that may be difficult. I personally wasn't able to do it in my own home, and it may be expensive, so tying it into the existing system may only be the necessary thing you can do in a renovation. One additional bonus to further improve your energy performance is the elimination of penetrations in the building envelope by eliminating the bathroom vents and instead just having them route directly to your recovery unit. Um, and the other thing, again, going back to the kitchen hood ventilation that I promised to get back to, LEED environmental quality ventilation requires 5 air changes per hour in the kitchen if you're not doing the direct out vent. So it could be dragged back into the recovery system. Some systems do, some don't. Some, don't go over the kitchen. They're just supplying the air over the hood range. They're just supplying air directly into the kitchen, not having the range direct them to the ERV. That's rarely are the ones actually doing that. Oops. So when designing these systems, the RedCalc tool makes it much easier to determine proper sizing of the ventilation system and to meet the LEED environmental quality compliance. This tool is currently free, courtesy of Pacific Northwest National Lab, through the U.S. Department of Energy. The ASHRAE protocols in 2016 and above allow for taking into account the blower door test for RedCalc. The program allows for entry of air leakage of an existing home or estimated air leakage of a new construction project to determine the true need for ventilation. Oftentimes, it results in lower amounts of ventilation needed than just the conservative chart that you saw at the beginning of the LEED credit library earlier on. Ironically, the more air leakage that a home or building has, the less ventilation you need to comply based on using these inputs with LEED or ASHRAE. But of course, your LEED points are also going to get dragged down as well, the leakier your building is, and the more health and humidity impacts you're going to have. So it's never a great idea. But let's turn it over to Victor here briefly to go into a little bit more about some advancements in our recovery systems.
Thank you, Brad. I appreciate it. And yeah, so this is a busy graph. Please bear with me. I'm the worst talking about history, and also please bear my accent. But in general, the graph, this slide shows the evolution of the minimum ventilation rate. So now the question is how much ventilation we need in our homes. to start designing our system. So early on, so the left side of the graph, it shows more about a graph that I took from a ASHRAE journal. Basically the ventilation rate progressed from 1800s to 2000. Basically, at the beginning, it was more a health focus because, but at that time, there was not even a mechanical ventilation system. It was more about opening windows. But for example, doctors are starting to see health effects, benefits on patients by opening windows, lower transmission of the respiratory diseases. So then when they're starting to set up those guidelines of providing those guidelines, and then to all buildings. At that time, the guidelines, it was more for all buildings, including residential. Then there was a point where they start thinking about more focusing on comfort. In the sense, it's more about comfort, is more about temperature, humidity. You open windows during the summer, there is a lot of humidity that it comes through with the air. So it's more about how comfortable you are inside the building. And they focus more, the standards start focusing more on other, kind of like that was part of the, basically of the comfort, understanding that 80% of some population will feel more comfortable with this type of ventilation rate. Later on, it was more about the oil embargo, where the United States had the need to basically reduce energy consumption, be more independent on energy, on the energy supply. So that's where they're starting to create all these building conservation standards, and the famous ASHRAE 90.1. That's where it was born in the 1970s, and then they started to build there. That's where actually they kind of like at the beginning they say, well, let's try to bring no ventilation into the building, and that's where they're starting to notice that ventilation, it was a major effect on health. That's where sick building syndrome came, people starting to go inside the house, the buildings, and then feeling not right. That's where they changed the ventilation standards are basically as what we are doing today. The right side of the graph, that's more I added on that based on some calculations, roughly about what is the type of ventilation rate that we are lately. So the ASHRAE standard has evolved. I show about 15 of the years, basically about um, some versions of ASHRAE 62.1, 62.2, that's for residential, and roughly it's about the ventilation rate per person is about 18 to 20 CFM per person. That's basically the recommended. So next slide, Brett. The next slide now is more showing about recent studies are more about, so the ones that we are talking about, all the standards right now, because it's all related to comfort and energy focus, is more other-based, adequate standards. But there has been a lot of research more related to, well, what happened if we double the ventilation rates, et cetera, et cetera. And now there is starting to have more of a universal research, how do you say, um, conclusion that if you want a healthy building, you have to be more into the 30 CFM per person. Still, the standards are not quite there, but that's basically what the research community is starting to be with more of a overwhelming conclusion. And what it means is basically, yes, now we have a lot of methods on how to measure health, a lot of monitoring of indoor air quality monitors, etc. And there, what basically the conclusion is, when you increase the rates, you have better sleep, better cognition, better productivity, lower exposure to respiratory diseases, etc. So that has been the conclusion. Now, if you go to the next slide, Brett, the question is, well, now, yes, we want to increase the ventilation rate, but we still want to bring air. Air comes with humidity. So how can we do that effectively, sustainably? And now, how can we do that also with no cost or reduced cost? And that's what we're starting to talk about: energy recovery and smart ventilation. The next one, Brett, please. So how the energy is recovered. So I think Brett touched on the energy recovery ventilation systems. There are two ways to recover. I would say 99% of the devices out there, they use the heat exchanger, a heat exchanger to recover energy. So they call it either energy recovery or heat recovery. And then there is another method to use to recover energy using a heat pump. And that's what we call it, the conditioning energy recovery or heat pump energy recovery. And I could explain that in a little more detail. The next slide, Brett. So when you use a heat exchanger, it's pretty straightforward. It's basically you put a heat exchanger to exchange heat, sensible and latent heat in some cases. Basically, you will have always the outside unconditioned, usually during the winter or during summer. So during the winter, it's too cold, and then you want to bring that fresh air to inside. So if you don't have a energy recovery, basically you use your HVAC system to basically to condition that air. So the way to do energy recovery is basically you already spend some energy conditioning the air that is inside. So we want to use that energy, and that's what we want to recover and use that energy to heat up, for example, the fresh air that is coming in during the winter, or cool down the air that is coming from the summer. Now, depending on the material of this heat exchanger, if there is some permeable, like a way for the heat exchanger to also have some moisture transfer, that's what they call the energy recovery ventilation. Basically, enthalpy. We exchange enthalpy between the two of them. So basically, usually humidity goes from high humidity to low humidity content, and that's basically what we are trying to do here with a permeable membrane inside the heat exchanger. Next slide, please. Now, conditioning ERV, they change, they work a little bit different. With the conditioning ERV, during the winter, for example, the polluted air, that's the polluted air that we want to exchange with fresh air. So the polluted air has the energy that we spend, not only from an energy standpoint, from a cost standpoint, that's the energy that we want to recover. So we use a refrigerant to absorb that energy. So the refrigerant will evaporate, and then we use the compressor to increase temperature and pressure for that, and then we warm up that fresh air that is coming from the outside. And then that's how we recover the energy with a conditioning ERV. One of the benefits here is that because the heat pump, we will be able to, you will be able to manage pressure and temperature. So we are able to provide a warmer, fresh air coming into the house. So basically we are reducing the cooling load in the HVAC system. The next one, and during the summer, it's also similarly, basically what we don't want is actually that energy that is outside, all that fresh air that is hot and humid to come inside the house. So we want to remove the humidity. We want to reduce the temperature. So that's what the indoor, the coil that is in that air becomes the evaporator. We absorb that energy. So the refrigerant inside evaporates. We use the compressor to increase pressure and temperature, and then we put that energy into the polluted air that is coming out. So it helps us to expel that unwanted heat outdoors. One of the benefits here is basically because of the coil that is in the fresh air side. It's cold, then there is some condensation there that it could just go to the condensate drain. I think the next one is for you, Brett.
Yeah, thanks, Victor. So, to kind of conclude our session on either, I think, and I like the way Victor has put it, we kind of either have heat recovery or conditioning ERV kind of systems. One way or another, these systems, and especially when it comes to LEED environmental quality ventilation prerequisite compliance, one thing that many people miss out is the fact that, users need to have full control of these systems and easily access those controls. I can't tell you how many homes or multifamily projects we see get built and it doesn't give the user any kind of control. And this includes being able to turn them on, turn them up, and turn them down and turn them off. That has to be able to happen. And so they need an operation and maintenance manual that actually makes sense. That's not in foreign engineer language. And they need to have training during the construction process to understand how and why to do this. And this is one of the benefits of the smart system that we're going to be talking about here in a little bit because it has all of these features. So, as the project is designed, built, LEED, Energy Star, green building certification projects, they'll require the energy rater to come out and do the testing on these systems. Maybe the code inspector is doing it if they're savvy in your area to determine the flow that match the calculations. And then if it's a good rater you're working with, they're working with your team to figure out why the ratings are off, why the flow isn't making it. What's the issue here? How do we resolve it? Let's come up with a solution. But hopefully your build team does such a great job, your HVAC team, that it should test out perfectly. Um, and really, at the end of the day, with the reality of the disbursement of these air quality, these cheap air quality monitors that are just coming down in price, and still are good, still are accurate. We're starting to find that this approach to these three different ventilation strategies we discussed, supply balanced or even traditional recovery, are either constantly underventilating or in many cases overventilating, or in worst cases, some days under and some days over. And we're now realizing that we need to go beyond the LEED standard and the ASHRAE standard to meet the next level of good indoor air quality, which is then also energy efficient. And so thus we enter the smart ventilation, which can both occur with or without recovery, and it can even occur without a balanced approach. But if we want to talk about all the good, better, best, and what we would imagine the best approach, we would argue you need to have balance plus recovery plus smart. And that is where I'm going to again hand it back over to Victor to kind of take us into that conversation.
Yeah, and then just basically continuing with the point is basically, yeah, it's a new paradigm. We have already now indoor air quality monitors that can help us. They're affordable and they're becoming more accurate. Where now we understand what is happening inside our house. So now we're measuring what it typically make us sick. And I see now ASHRAE standards moving towards that direction. Now creating more when you are designing a new home, basically designing the ventilation rates basically based on pollutant levels, basically pollutant concentrations to keep the indoor pollutant levels within a safe and healthy limit. So basically you set up the pollutant levels that you want in your home, and then basically the ventilation rate will be designed to keep that ventilation rate yes, as for a healthy home. So next slide, Brett. And yes, and now it's more about probably more, most of you already have an indoor air quality monitor at home. And now it's more about, well, my CO2 is very high. So you open a window then until it gets low, or turn on some equipment here and there to basically to try to keep those the red levels that your indoor air quality monitor is showing you. So to make them green. But now it's more about a system that can do that for you. And it's more about that feedback. It's basically connecting that feedback of the indoor air quality monitor, that signal that it's basically measuring to the HVAC system. And it's more about monitoring. So you monitor the pollutants, and now we're able to measure carbon dioxide, organic gases like VOCs, particulate matter. We are able to measure that. And then let's compare those with some healthy thresholds. What are the healthy thresholds that they are recommended by the latest standards or research community and so on? And then if it's high concentration, that's where the system should work for you, act to reduce those pollutant levels. So increase ventilation, filter, whatever you need. Basically, that's the smart system. And then if it's low concentration, basically you are in a good shape there inside your house, and then that's where you will be saving energy as well. Next slide. And then it's more about the indoor air quality guidelines. It's basically now is more about research understanding. Now we have better indoor air quality monitors. We have also the research community has also a lot of devices, approaches to understand what it makes us sick. And then it's basically defined what are those guidelines. I think most of the indoor air quality monitors said that for a healthy home, you need about carbon dioxide less than 800 parts per million. But we are able to measure now with all these affordable indoor air quality monitors, we're able to measure carbon dioxide, particulate matter, volatile organic compounds, carbon monoxide and radon, they have a different approach. Carbon monoxide is basically an alarm. It's basically get out of your house because there you have a problem inside. And then radon is more about mitigation approaches to not let that radon to come inside your house. But in general, it's basically create that how do you say that signal, or basically that feedback from the monitors to your system. Thank you, Brett. I think that's our last slide.
Yeah, thank you, Victor. And so that officially concludes our continuing ed portion of this session, but we're going to jump into Q&A, and then after Q&A, we're going to hand it back over to Victor just to talk more specifically about utilizing these systems for your home or for your projects, and what that would look like to get these more advanced demand controlled smart systems. So real quick before we jump into the Q&A, just a reminder that yes, this session is being recorded. You can check our YouTube channel here in the next week to access it, or you can go there right now, click subscribe, and you'll get an instant update when it is available. For those of you watching this in the future, not right now, take a quiz with an 80% passing rate, and you'll receive your continuing ed. For those of you here live today, make sure to check your spam for certs at gutenbergcerts.com. As long as you've been here for the entire CEU hour and have the name written in your Zoom that you want written on your certificate, and you're logged in with your proper email, you'll receive this in the next day or so. And as always, before we get into those huge questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 500 members. We're trying to get there by the end of the year, and we hope you'll support us in our 25th year anniversary by becoming a member, helping us reach our 500 member goal, and all of our sponsors who allow us to do what we do. Ream for decarbonization in water heating, heat pumps, Build Equinox for smart demand controlled ventilation, Tamarack Ventilation for upgrades to homes to ensure better proper airflow, and ultimately other systems. So yeah, some questions did come in, and I wanted to quick address them. There was somebody asking if ASHRAE 90.1 could be used on single family homes, and two things. Number one, first of all, from a lead standpoint, no, you cannot do that. And then from a technical standpoint, I don't believe the 90.1 system is designed to do that. You really start to lose its ability and function of being able to estimate modeling at around less than 5 units, I believe. So you really want to use that energy rating index, that HERS, which can also be used on larger, massive 5-story buildings. So look into that. The other question that came in was, and I'll hand this over to you, Victor, is if people are using these recovery systems in place of the bath fan, how can they ensure that exposure to odor or methane is, not occurring or is reduced?
Yeah, that's a good question. In general, I would say it's basically it's when you turn on the ERV for a bathroom application, it's just going outside. It's go directly outside. It's basically going through the ducts, similarly what you have inside. So yes, there is gonna be some if you are using an energy recovery ventilation, there might be some uh, uh, because of the permeability of the heat exchanger core, they might have some
Uh,
transfer there, but I'm not sure is how much or if it's something that it could
yeah,
be problematic. We haven't seen anything that it has reported that,
yeah.
but I would say that in general it should be safe.
Yeah. Now I know I personally, have my fans set to like 100 CFM, and that certainly does the job. That's a little bit a lot. I mean, and that's just point source. I know that the Energy Star standards per lead reference 25 CFM at if you've got a continuous system, and then most bath fans they want them all tested at 50 CFM. So I guess the question I'm getting at is, I know some of these systems have a boost feature for those who are concerned. Do you know if typically that can occur with like these smart demand controlled systems, if they can have a boost if someone is concerned?
Oh, regarding the man control ventilation, yes, yes, there is a boost that basically overrides the normal
Uh,
operation and then run it. But yeah, in general, I would say yes. It's basically meet the standards. I would say that if there is
yeah.
a bathroom that is connected
Hmm,
to an ERV, it's basically on make sure that the ERV is running at the
hmm,
right ventilation rate that
hmm.
it was recommended. And similarly, it's more about the ERB is basically is going to evacuate that air out. It's just that it's trying to recover that energy to and balance, because also that's another one is if you don't balance the ventilation, probably all that air is going to come through infiltrations from somewhere else that you are not controlling.
Yeah, yeah, yeah. And so another question that came in here was, can we use absorption refrigeration cycle for heat recovery instead of compressor cycle? And so one of your Ty there, thanks for helping out, Ty, said, yes, absorption cycles can be operated similarly to vapor compression. Victor, I don't know if you want to add anything to that.
I think similarly, it's basically what we are trying to do is basically recover. Yeah, the main purpose of all this is try to recover that energy. We are now more wanted to conserve energy cost, bringing fresh air in is going to cost us. So we are trying to recover that energy. We using that. So yeah, definitely
Mm,
any like the using the heat exchanger, using a heat pump, or
mm,
using an absorption system should be able to do it. What is the energy? That we want to recover is the energy that is coming out.
mhm.
And then during the summer is the energy that is coming
Yeah.
in. We don't want that energy to go inside the house because we have to pay more.
Yeah. Another question is, what are the best indoor air monitors? And so I'll take the first crack at this. I've been testing out, I don't know, five, six different ones. And what I can say, and we're putting a session together. We're going to have a whole session on this. I promise you all. I've been saying it for a while. But what I can say in general is that most of these air quality monitors are, I can't tell you that they're accurate, but what I can tell you is that they are responding in the way that they should be based on the events that are occurring, and that they seem to be giving numbers yielding things that should be happening based on the things I know about my house and my system. So I can't tell you they're accurate, but I can say that they seem to be reporting correctly, except I have one device that got shaken quite a bit by a kid, and then it got dust in it, and now it's reporting very high levels of PM 2.5. I won't name which device that is. You can send me an email. So that's been annoying. So I just have to know that the PM 2.5 isn't 40 in my house. It's a lie. So then I have to just watch if it goes above the 40. So there's that. But yeah, there's a lot of great systems out there. So stay tuned. We'll do more on that, and feel free to contact me if you have questions. I don't know, Victor, if you have any other thoughts on that too.
Similarly, yeah, for example, similarly, I have tested quite a few of them and I have been comparing it, calibrating them, etc. So basically put those in the same test chamber just to
Mm,
run. I would say that in general, yes, all of them are basically, how do you say, they are providing similar answers. Yeah, there are some accuracy there. Usually, I would say CO2 and particulate matter. Probably
mm,
there, those are more, I would say, good measure, good pollutants to measure, or
yeah,
we have more accuracy. VOCs depends on the manufacturer.
yeah,
Some of the sensors are more sensitive because VOC is just a mix of gases.
yeah,
You cannot able to say, oh, this is coming from. It's just a mixture of gases, so you don't know what you're measuring. Some
yeah.
sensors are more sensitive to some other VOCs, etc.
Yeah, yeah. And I'm glad you mentioned VOC, because one thing you have to watch out for with some of these systems is they use or carbon dioxide equivalents. So they only measure the VOCs, and then they try to guess the carbon dioxide. And in my experience in those cases, that is wildly inaccurate. So watch out for those. And then other systems will give you basically I haven't seen a dew point one, but they give you mold risk, which is great because that's, humidity plus temperature plus time. And a lot of your systems might report high humidity, but it may not be a real issue, or the other way around. So I like some of these systems are giving out mold risk indicators. So look out for those. Um, Final question here, and we're going to go back to questions if you want to stick around, but we're going to shift gears a little bit. But final question here is, does Passive House guidelines provide healthy ventilation? So I can't speak to Passive House International other than to say I believe so. But here in Passive House US, They have hitched themselves to the EPA Indoor Air Plus standard. And again, not a perfect standard. Doesn't mention smart control ventilation, right? It doesn't mention air quality. But in general, if you're following the Indoor Air Plus standard, you're going to get a really good, in my view, pretty healthy building. So my answer is I would say yes, Passive House does do a lot of health considerations as far as ventilation goes. So, hats off to them. So, Victor, I'm going to turn it over to you now, though, to just catch us up on, again, specific products through Build Equinox that can be used to help people with their projects.
Excellent. Thank you. Can you see my slide?
Yeah, it looks like our slides for this presentation. Yeah.
Excellent. Okay, excellent. Great. Yeah, so thank you, Brett, for the opportunity to talk about the CERV from Build Equinox. So my name is Victor Nino, Director of Business Development, and please, my email is simple, is victor@buildequinox.com if you have any additional questions. But yeah, so we had half an hour to talk about ventilation. I hope we were able to do a good job there. But ventilation is it's we want to use basically all of them. So there are different mechanisms to reduce pollutants. We talk about ventilation. Ventilation is basically diluting pollutants by bringing fresh air in. We are able to dilute gas pollutants, fine particles, biological aerosols. Filtration also has an important job to do. Basically, is to remove fine particles, biological aerosols, and then disinfection. That is basically the most recommended one is UV light. Is more about deactivating aerosols and so on. So there are different mechanisms to reduce pollutants. And from our point of view, the most effective system is the system that use them all. So now we're not talking about just ventilation, filtration, or disinfection. We're talking about the whole, all the mechanisms. And there is one more that is not here, but it's source control. And I think source control is more about, now is more about the designer, the builder, developer selecting materials, making sure that the airtight homes, there is no humidity management, etc. That is more integrated into the design of the house. But now this is more about the equipment side. Yeah, so in the half an hour before I explain the energy, how we do energy recovery. So there are two ways to do it: using the heat exchanger or using a heat pump. The CERV uses a heat pump. We are moving heat instead of transferring heat. So we use the refrigeration cycle to move the heat from one stream, usually to the other stream. What it does is basically we provide conditioning because we are able to manage now the compressor to increase the pressure and temperature of or reduce yes, in other words, control the refrigerant pressures and temperatures to provide the conditioning that the air needs. So basically, it will be already conditioned before it comes to your house. So now what is the major difference? So now from an energy recovery standpoint, that the difference of the service, basically we use a heat pump energy recovery ventilation. So most of the other equipment uses the heat exchanger core. What it stands like one of the major differences that it comes as a standard feature is the demand control ventilation. As we were mentioning about it, is like we're creating smart systems in the sense that we have to create a feedback between what the quality of the indoor air into the system. So we are monitoring carbon dioxide, volatile organic gases, volatile organic compounds, and then we are going to bring fresh air only when it's needed. That's one of the standard features of the CERV. And one of the things that we also created is because we know filtration is also important. Sometimes dilution is important, but sometimes it's safer and not safer, no, more cost effective just to move air around the house. So we have a recirculation mode. So I think is one of the only ones, ERVs, that create that whole house air purification. We have recirculation mode. We close dampers. We don't let any fresh air coming in, and we just recirculate that air through the filters. And there are some optional features in the last year under the leadership of Ty Newell, we have worked a lot on particle defense, but it is more about monitoring indoor and outdoor particulate matters, and now create a smart system that decides what to do when the indoor air quality is particles are high inside or outside bad. And then there is also a option to add UV light for some more sensitive people that they're to trying to kill. Is after the filtration system, there are some still filters are not 100% efficient. There are still some things that they're gonna go through and then use the UV light to kill those biological particles that they are passing through. Yeah, so the CERV has this whole house air purification system. Basically, we have some integrated dampers that it could switch from ventilation to recirculation. We use high efficiency filters, MERV 13, 14 into the streams. So the CERV acts as a whole house air purifier because we have a heat pump inside. So we are able also to provide some supplemental heating during the winter or supplemental cooling during and dehumidification during the summer because we have that heat pump inside our system. So now it's more about what we're gonna do. Usually the outside air is not always fresh. So what are we gonna do about it? So there is some people that they have different sensitiveness to fine particles, pollen, just basically busy roads, or nowadays these wildfire smoke events that they are happening more frequent than what we want. So the CERV is now providing that solution. It's basically, well, first we are going to filter that outside air using a high efficiency filter, the air that is going through the CERV, but also we have optional sensors to track outdoor VOCs and particulate matter to manage fresh air intake and basically decide when not to ventilate. So we just recently, and this is a great opportunity, Brett, to announce that we just launched the particulate defense. Right now, if you are a CERV owner and you already have a CERV, you can purchase this particulate defense and install it in your own system, or you can order one with this particulate defense. But basically, we're measuring particulate mass and particulate count both indoors and outdoors. So basically in a how do you say, normal operation, when the indoor particulates are high, then there is ventilation mode. It will replace polluted air with fresh filtered outdoor air. So we use ventilation to reduce those particulates. What happened is when outside is really bad, and I live actually in Milwaukee, Wisconsin, and we just a couple of weeks ago we went through a crazy wildfire smoke event. From it was coming from the west. This map shows that it covered Minnesota, even Michigan, where Brett is located. And now it's more about if the outdoor particulates are high, then don't bring that air. Then close the dampers and then run in air purification mode. So now we are focusing more in the filtering part of the CERV system, and then we'll recirculate that air because usually there are some infiltrations in your house. So those are the ones that we want to remove as well, and postpone that normal ventilation until the outdoor quality is better. So this is one of the latest innovations that we added to the CERV. And we have data. This is actually the data of one of the houses here close to me, where I basically was targeting this, the outside particulate matter. It was in the levels of 80 to 100. We are measuring here in micrograms per cubic meter. The healthy levels that is basically the recommended is 10. So basically it was 10 times the healthy recommended levels. I installed the system, the particulate matter kit here, the particle defense in this here, and it was basically now the CERV or the system knows what is happening outside, and now it's able to make decisions. So basically close the ventilation, the dampers, and then starting to prioritize filtering, air purification, and that's where you see that basically significant drop in particular matters out inside. So before, because the CERV didn't know what was happening, the particulate matter was in the 30s, even though this is a modern home, not a airtight level, but it was pretty airtight from a modern home standpoint of view. The home integration, so basically we are, the CERV can be integrated with any system. So we work with Air Force air systems. We work with hydronic, basically systems. Basically, yes, the CERV could be just having the dedicated ductwork, or the CERV could be integrated with your HVAC system, share the supply, or share both supply and return ductworks to provide that basically that indoor air quality monitoring and management system. So the best practices that we usually recommend to homeowners, designers, etc., is more about usually provide the supply in dining rooms, living rooms, bedrooms, and then basically install the returns in the areas where there is high pollution, high humidity, like bathrooms, laundry. The kitchen, it has its own basically its own requirements, because usually there are some requirements based on standards, based on code, that you might need still to have that how do you say the basically the range hood exhausting air directly outside, because you might have a gas stove in there. So that will be, but in general we have we ask to put a return near the kitchen area to back to the CERV. So now boost ventilation, I think that was one of the questions. So yeah, so in normal operation, we measure CO2 VOCs and then make decisions based on the levels. But you will be able to override those. For example, if you're using a bathroom or you're using a kitchen, then we have basically these ventilation triggers where you are basically telling the CERV when to basically run in ventilation mode. Even if the CO2s and VOCs are still in the right level, this will be basically, it will override those, it will run, and you will be able to run at a higher ventilation rate than the normal setting that we usually recommend. Zoning, it's something that some people have been very happy with. It's basically more about controlling the area where we wanna have more ventilation drop from. So let's say that you can put dampers. The dampers could be connected to the CERV, and then basically send a signal. And then I'm sorry. So if let's say if there is one person using the bathroom, so the trigger will tell the CERV, hey, I'm using the bathroom. Then the damper will keep open, and then it will close here. So basically, all the return air is gonna go through the bathroom, increasing the ventilation rate. Yes. So any additional questions? I appreciate Brett for this time for us to explain the latest capabilities of the CERV and some and basically, yeah, the standard capabilities of the CERV. And please contact us. Our website is buildequinox.com, and we have solutions for residential, and then also new we have a solution for classroom and commercial.
Yeah. Yeah, great. Thanks, Victor. So, yeah, like I mentioned, everyone, from the continuing ed standpoint, we've been all set here for the last 20 or so minutes with you all. So we're just sticking around now and specifically talking about Build Equinox, but I'm also happy to jump into any other questions I missed previously on ventilation. So we're just going to stick around and keep on going. And for those of you who want to keep asking Victor questions or about, even about your own specific projects, we'd love to answer them. So we have one here. Is the CERV 2 capable of handling Zone 2 Gulf Coast humidity levels of fresh air without supplemental dehumidification?
Yeah, that's a good question. A great question. At the end of the day, is basically understanding where that humidity comes from. If it's from the outside, well, definitely airtight envelope, it will help. So, but yeah, we have a capability. So the capability is basically from a ventilation standpoint, we will be able to remove all the humidity that is coming out from the outside. That's how the CERV was designed. Now, from a recirculation mode, now that's where basically it will act as a dehumidifier. We have a limit about 9 liters per day, and that's basically. But yeah, but there is it will depend on how airtight is your home and how
Yeah.
much humidity you are creating inside your house. For example, if a person that is cooking and so on. So I would say that I'm not sure if you are able to do the calculations about how much humidity you need to remove. But in general, we have a
Hmm.
9 liter per day of humidity removal in recirculation mode. That's the one that you will use. But if you need more, then that's where you need a dehumidifier to be paired with the CERV.
Yeah, and I'm glad you mentioned that. So we actually did a webinar not that long ago about tools to estimate and forecast, just like we do energy modeling, forecast potential humidity risks. So I'm going to drop that into the chat. So for those of you even building new or doing renovations and you're trying to forecast that humidity, check out this free tool that's out there. But I know one of our lead platinum projects in the Chicagoland area was concerned and added in a supplemental dehumidification system right into the serve. What are your just advice on doing something like that if someone feels concerned?
Oh yeah, so that's one of the features. I think I had a slide for that.
Okay.
Let me see if I have that one slide. I think oh, I think I deleted. But yes, in general, yes. So the cell will be able to communicate and manage basically the dehumidifier if you need to. So there
Mm,
is some because we have a very sophisticated controls that we are able to how to say
mm,
to get the monitors, the indoor air quality monitors, the signals for the dampers and so on. We will be able to also control the humidity, the
mm.
dehumidifier, sorry, to basically, if you set up a certain humidity level, the CERV should be able to manage the dehumidification from the CERV and the
Yeah.
dehumidifier to meet what you're looking for.
Yeah. Well, great, everyone. Keep questions coming here. Like, what are you all working on right now? I'd love to hear from you in the chat. What is your ventilation strategy? Um, what questions do you have if you wanted to update your ventilation strategy to the serve? Let us know. We're here still just chatting and having a conversation. So let's talk a little bit about um, I guess, outdoor air quality. And kind of one of the questions here that came in was just, confirming that your outdoor air defense, that really is an add-on to the system, and it doesn't necessarily come standard, but you said it actually can be added on to existing systems. Does that even get added on to the existing standard serve or only serve two?
Oh, that's a good question. Yeah, I believe is the CERV tool, but probably we will be able to add it to the original ones. I think
Okay.
most of the CERV tool is the one that they are the most popular. But
Yeah.
yeah, in general, it's pretty simple, straightforward. We have some guidelines, videos, and of course, you can call us anytime to for us to help you to install that. But it's basically two. Basically, there is two boards. One in the
Yeah.
indoor that is measuring CO2 VOC and the other one in the
Yeah.
outdoor. The outdoor, we put those particulate matters in both of them.
Yeah. So I think about yesterday, I was looking at my air quality EPA monitoring app, and I'm still like amazed that it even works and it hasn't been shut off. But well, that's great. So I'll take it. I'll take it. And it was reporting high levels, and I look and it's sure enough, it's ozone, and I'm like, ah. So my system is set up where I've got a MERV 13 on my ERV, and then a MERV 16. It goes into the 16 into my heat pump. And so for the most part, I've noticed as these wildfires escalated, we still hold pretty steady, even keeping 100 CFM pumped into the house with that bad PM 2.5 outside. The PM 2.5 was getting up into the 150, 160, and still my house was, maintaining, maybe got up to 15 or 16. but it wouldn't go that high. And that was only for a couple times. So we just kept it on. But ozone, if I understand ozone right, like that just goes right through everything. It's like a ghost, right? There's nothing that can stop it. So do you have any thoughts on, your system's next level for handling ozone as we might face that threat?
Yeah, I would say that that was a good. We had some discussion with a client on ozone. I would say that it's more about the filter capability of absorbing.
Mm,
So there are carbon filters. Also, I would say it's a very unstable chemical. It reacts with other chemicals. So yes, so I would say that is sometimes filters could be improved with carbon filter or VOC absorbing that it could improve your system.
Do you know if the ability to monitor it, like on a system like yours, would take a lot of effort to say, oh, because it's one thing for the EPA have to say it, it's another thing to know what's at your actual house, right? And I mean, do you all look into a system where it might say, oh, the ozone levels are getting high, we're going to also shut down and go into recirculation mode?
Yeah, that's a good recommendation. I will say I'll talk to Ty and the
Yeah,
team and see what we can do about it. If it's
yeah,
starting to be more of a yeah, but
yeah,
that's a great another step further to a healthy home. Is more
yeah,
about outside is becoming
yeah,
really concerning,
mm,
and I will say also the ability to be able
yeah,
to either ventilate,
yeah,
filtrate, absorb now with some absorption
yeah.
technology to do that.
Yeah, and to be fair to Victor and Build Equinox, I don't know any system that does it. It really seems to be more of a user control, right? Like someone has to be like me checking the system and then shutting it off, right? Or a building maintenance person in multifamily. So, but that's rare these days. We're also overwhelmed with so much that not normal people are doing that. So it's just another one of those things like where can technology solve those issues. So I mean, I know that because your system has the heat pump in it, oh, I'm sorry. I do see some questions coming in here. So what is the operating cost of the Serve 2 per year kilowatt? Or I know money is hard to figure out because that depends on the local grid, right? But maybe you can speak to just like kilowatt hours.
Oh yeah, so I made some calculations recently. I could go dig in, but yeah, in general, it's basically let's see if I can find it fast. But why don't you email me the person? Maybe we can discuss that in more detail. But let me see if I are able to do that calculation quickly. But yeah, if you go to buildequinox.com,
Hmm.
there is specifications where you will see the consumption, the fan consumption,
Yeah.
and the the basically the compressor consumption, the power.
Right.
Basically, those are the two the two devices, the two components that are drawing power. The question
Yeah.
is how long you're gonna run this, and because it's not a timer. So it's like, oh, I'm gonna run it 50% and then 50% we're not. This is more related to carbon dioxide and volatile organic compounds. So we have some basically our own software called zeros that can help us to understand what is the percentage that you are running. So sorry to the long answer is yeah, we have a model capability within, it's free, where we can calculate, where you can calculate the kilowatt hours of the use of the server, because it's not very straightforward. In other words, we have to understand is how many people you have in your home, what is the envelope,
Yeah.
the size of your house, because we understand now is how much CO2 will be
Mhm.
released into there, and now how long or how long the server is going to run in order to do those calculations.
Yeah. Well, and that kind of set up the question I was thinking right before I read it, and that was, the idea of because your serve has the conditioning capabilities, where I assume part of the answer to your question is climate, right? Like it's going to be very different in a mild climate versus an extreme hot or an extreme, especially cold climate, and you're relying on that conditioning system. So that kind of gets into my question, like, where do you think, if at all possible, either now or in the future, you could get away with this system being the sole conditioning system of a ideally a near passive house built home or multifamily building or unit rather.
So if I understood the question is basically where, if there is going to be a system in the future that is going to do basically now ventilation and conditioning.
Right, because your
Uh,
system does that. It's just, can it rely only on that and do you, instead of having that ancillary heat pump?
yeah, so I would say that it's coming. I think we are as a just as a how to say as I forgot the name, but anyways, yeah. So we are working on that. It
Mm.
depends. Like for example, in the refrigerants, it's starting to be a little more
Oh yeah.
focused nowadays. We are doing some research, and now we have
Mm.
some test units using R290. R290 is basically
Yeah.
propane that from a thermodynamic standpoint of view, it's a
Mm.
great refrigerant.
Hmm.
And now with running propane inside the serve, we will be able to actually increase the capacity of the serve now. And of course, nowadays also the amount of cooling load and heating load that is needed in the house is starting to reduce because now we are learning and learning and learning, so we are able to start to match that cooling capacity with a serve unit, so it can does basically everything what we are looking for: ventilation, filtration, and then comfort conditioning as well. But in some
Yeah.
small units, we are doing it right away with this system
Oh,
because of
great.
the because of the size. It depends on the size, but also because it's very well built at very high standards on
Yeah.
insulation and air tightness.
And is the challenge more on the heating load or cooling load, or is it more in the places where they tend to have both extremes?
Yeah, I would say that it will vary, but in general, yes, I think it's yeah, actually, I'm not sure because it depends on humidity levels and
Sure.
on the
Yeah.
temperature levels. Yeah.
Okay. Well, and so thinking about the workforce here, and I know our HVAC contractors are just overloaded right now, and the idea of bringing this on as an opportunity to offer this, or if someone has their favorite mechanical contractor, HVAC contractor that they want to do it, what do contractors have to be certified by you all? Are there any training or I guess on-site commissioning to make sure proper install? Like, can you just talk to us a little bit about that?
That's yeah, yes, and I'm very happy that you touched on that and someone asked for that because basically yes. So there is no difference between installing a serve with an ERV system,
Okay.
because first of all is basically you need the two penetrations. That's actually the most labor intensive. Is
Mm.
just creating those. If you're in a how to say in a
Mm.
current home and you don't
Yeah.
have ventilation inside, it's basically creating that. But in general, basically
Mm.
the serve, even though we have refrigerant inside, is a compact hermetic unit. It's like
Mm.
your refrigerator. Your
Right.
refrigerator, you have basically a heat pump system there inside with refrigerant, compressor,
Yeah.
etc. So we don't. There is no the HVAC installer shouldn't be able to install anything like that. We had also 110 volts, so it's just a normal voltage. So it's 110 volts, and it's just a hermetic unit. So there is nothing outside, or there is no pipes that it has to be connected from the outside to the inside. It's just a standalone unit. The only thing that you need to do is basically the four ducts that you need to
Mm.
connect, similarly to an ERV, and the two penetrations that you need to add to the house, basically to breathe to bring the fresh air in and then exhaust the air out.
Yeah. And then on the commissioning side of things, I know because you have conditioning in your system, and I know ducted heat pump conditioning is start or commissioning, sorry, is starting to become from a like, hey, we don't know what to do. Now we're starting to refine it. There's our friends at Measure Quick on how to test these systems, static pressure, and then of course you bring in the ventilation component. So do you have commissioning kind of guidelines, standards in place that like what is it that when someone walks away that they should feel confident that it's working? Or is it just look at your bills, look at your air quality and the metrics, right? I mean, there's that aspect of it too. So
Yeah, so right now I would say that the current standards is basically work with us. I would say that
Hmm,
just give us a call in the sense of if there
yeah,
is some particular question related to commissioning the CERV
hmm, yeah,
services. I would say we wanna we know that the system is basically best engineered system out there. It's just that we want you to use it, but definitely we want to work and just understand also what is the specific points of it of this certification or for this
hmm,
commissioning that you guys are addressed, so we are addressed
hmm,
that better. So I will
hmm,
be say yes, I will be happy to talk with any of you to
yeah,
discuss that in more detail.
yeah. And then there was a follow-up question here about people who are just trying to get I guess documents or resources or marketing materials. So if they're working consulting on projects that they can have these materials available. Is that something you all provide?
Oh yeah, for sure. And go to buildequinox.com. We have doing a job there is just to trying to
Hmm,
provide a lot of information, not only on the ventilation part or how the system works, but also on indoor air
hmm,
quality. There is quite a few literature, publications, and so on that talks in general about indoor air quality, humidity management. So yes, and then my email is victor@buildequinox.com for any questions that you might have, specific questions that you don't find
yeah,
in the buildequinox.com website. I don't know
yeah.
if I
Yeah.
was able to answer that question.
Yeah, I think so, and I see ties behind the scenes here helping out answer too. So, um, well, yeah. So I don't really see any other specific questions. So we are going to send out a follow-up email with just some more information to everyone who signed up here, and you'll have Victor's contact information in that as well. So I guess with that, yeah, I just remind everyone again, Victor, where can go people can go to learn more and hopefully move forward on their next project with a CERV.
Yeah, so buildequinox.com is the way to go. There we provide more description about the system. There is a form there where you can fill out for more information, where we can sit down and set up a quick virtual meeting to meet and talk about the specifics of projects. Usually the discussion is about how can we integrate it to your HVAC system. You might have some ideas. You want to go hydronic, you want to go with forced air systems. There are some configurations where you might need some zoning. And also is more about understanding how we're gonna do kitchen ventilation and bathroom ventilation integrated with the CERV.
Yeah, yeah. Well, great. Thank you so much, Victor and Ty Newell, hanging out behind the scenes, answering all the tough questions. So thank you so much for that, Ty. I appreciate it, and good to at least see you out there. And yeah, so thank you so much. Thanks to Build Equinox. Check them out at buildequinox.com. And take care, everyone. We will catch you here next week, same time, same place. So goodbye.
Excellent. Thank you so much, Brett. Thank you, everybody.
Yeah.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.